Very good morning. I'm Sonam Dubey, Assistant Professor in SIRT, Bhopal. Now, today I'm discussing about the concept of Aloha. Aloha is basically a multi-access protocol. It is basically reside in data link layer. Before explaining the Aloha system, we are generally introduce the concept of OSI. OSI is nothing but an open system interconnection model that is basically consists of 7 basic layers. In which the second layer, the data link layer, consists of 2 layers, that is logical link control layer and media access control layer. Now, the introduction of Aloha. So the Aloha is a multiple access protocol for the transmission of data via shared network channel. It basically operates in a shared network channel and it operates in the medium access control sublayer of the data link layer. And by using this protocol, we can just several data stream originated from the multiple nodes are transferred to a multiple point transmission channel. Now, the Aloha is basically categorized in 2 parts. That is, the first one is Aloha, and the second one is slotted Aloha. Now, the first one is pure Aloha. In pure Aloha system, the time of transmission is continuous. And whenever a station has an available frame, it sends the frame if there is collision and the frame is destroyed. The sender waits for a random amount of time before retransmitting it. Now, and the second one is slotted Aloha. In slotted Aloha, it basically reduces the number of collision. This is the basic difference between pure Aloha and slotted Aloha. In pure Aloha system, the time of transmission is continuous. But in case of slotted Aloha, the number of collisions reduced and it also double the capacity of pure Aloha. So we can just say slotted Aloha is the best policy of among pure Aloha. In slotted Aloha, the shared channel is divided into a number of discrete time interval called slot. That's why its name is slotted Aloha. But in case of pure Aloha, the time is not divided into any intervals. And in slotted Aloha, a station can transmit only at the beginning of each slot. But in case of pure Aloha, it can send, it just wait for a random amount of time before retransmitting it. Now, pure Aloha, the mode of random access in which user can transmit at any time is called pure Aloha. This technique is explained below in a stepwise manner. Now, the first step is in pure Aloha, the node transmits frames whenever there is data to send. That means whenever we have to send data from sender to receiver side, so it is already ready. And step 2, when 2 or more nodes transmit data simultaneously, when there is a chance of collision and the frames are destroyed. That means if there are multiple nodes that get some data and we want to transmit the data simultaneously, in that particular case, so there is a chance of collision and the particular frames are destroyed. Now, the third step is in pure Aloha, the sender will expect acknowledgement from the receiver. That means whenever the sender sends any data to the receiver, it will accept from the acknowledgement from the receiver. That is the surety from the receiver side. That means the data has received from the receiver. Now, in step 4, in if acknowledgement is not received within a specified time, the sender node assumes that the frame has been destroyed. That means whenever the data is sent by the sender to the receiver, it is wait for some acknowledgement. But in that particular case, if the acknowledgement not received by the sender, so the sender node assumes that the frame has been destroyed and it resends the data again. Now, in step 5, if the frame is destroyed by the collision and the node wait for a random amount of time and send it again. So that means in the case of pure Aloha, there is a chance of retransmission. This waiting time is maybe random, otherwise the same frame will collide multiple times. Means if there are multiple nodes send the data at the simultaneously at the same time, so there is a collision. In step 6, therefore pure Aloha says that when the time of period passes, each station must wait for a random amount of time before retranscending its frame. Now, so this is the block diagram of pure Aloha. In this diagram, we can see there is a three packets: packet A, packet B, and packet C. Now, the next one is slotted Aloha. The slotted Aloha is explained below in a stepwise manner. Now, the step first, slotted Aloha was introduced to improve the efficiency of pure Aloha because in pure Aloha there is a high chances of collision. That means in slotted Aloha we can just improve the efficiency as well as the capacity. Now, the next one is step 2 in this protocol. The time of shared channel is divided into discrete intervals. That means if our time is divided into multiple slots, so, so each and every station has a particular time period for transmission of data. So there is a less chances of collision. And these intervals called as slots. The station can send a frame only at the beginning of the In this protocol, the time of shared channel is divided into discrete intervals called the slot. And in step 3, the station can send a frame only at the beginning of the slot. And only one frame is sent in each slot. And now the step 4 in slotted Aloha. If any station is not able to place the frame onto the channel at the beginning of the slot, that is, it misses the time slot, then the station has to wait until the beginning of next time slot. That means if a particular station has not anything for sending the data, and that particular time it has to wait for some time. And after that time period, the next station send the data to the particular destination. Now, in step 5, in slotted Aloha, there is still a possibility of collision if two stations try to stand at the beginning of the same time slot. But in case of slotted Aloha, there is still a possibility of collision because if two stations try to send data at the same time at the beginning, so there is also chances of collision. So in that particular situation, there is also chances of collision. And now in step 6, the user are restricted to transmit only from the instance corresponding to the slot boundary. Now the users, in this case, users are restricted to transmit only at the particular time period, not at the same time. Now, so this is the available period. It's only one time slot. It is shown below. In this slot, we can see there is two packets, packet A and packet B. Both are signing at the same time. So in that particular case, no data is received by the receiver. So all the data may be corrupted. So there is a chance of collision. And this time period is said to be a vulnerable period. Now, so we can summarize that the slotted Aloha is best among the pure Aloha because in pure Aloha, there is a chances of collision. But in case of slotted Aloha, it reduces the collision as well as it high up the speed and capacity of the channel. So we can just refer the next one that is slotted Aloha. Now, thank you.